PID tuning is very often thought as an advanced step in your 3D printing career because it adjusts really small features in a print, and if you're a maker that doesn't do a lot of coding, it may be a little bit unnerving. But today we're going to go through every single step nice and slowly to get your printer as calibrated as it possibly can be. First and foremost, PID tuning is known as proportional integral derivative. It is a fancy way of saying that when it reaches a certain temperature, that'd be for the nozzle or the bed, it reaches and stays at that. It doesn't go too high and then cools down to go too low and back and forth and back and forth. It reaches it and it holds that value perfectly. In engineering, we actually find this all the time. We call it a closed loop system. The best example is a thermometer in your house. If you say, I would like to heat up my house to 75 degrees, your house will then heat up, reach that temperature, and because there's an installed thermometer, as soon as it reaches that value, the heater turns off. And as soon as it gets too cold, the heater then turns back on again. So we form this sine wave as we go along, and the same thing happens for 3D printers. But unfortunately, some printers have too high of a fluctuation, where your hot end temperature might get as high as 5 degrees over and 5 degrees under, and that variation can cause really bad effects in your print. Even more so, if you have a bed that fluctuates too much, you can actually cause really bad surface quality, even though everything else in your machine is dialed in spot on. With this PID tuning, we are making those highs and lows as small as we possibly can, so we can keep the most consistent temperature along your entire print. To perform this test, we're going to be using a software known as Pronterface, and it basically works by having us heat up our nozzle to be really hot and then cool down and then cycle through those a few times, and it will give us an actual mathematical value of our sine wave. And as soon as we can put that back into the machine and then save our settings, then when it reaches that temperature, it will hold it perfectly. And we're going to be doing this for our hot end and for our bed. So we're going to go ahead and download Pronterface. It is a completely free software that allows us to work in between our 3D printer and our desktop at the same time. So we're going to go ahead and download the most recent version. That's going to be either your Windows or your OS. The most recent one is the 18th of November 2017. This is a zip file. So you can go ahead and unzip it, and in it there will be a .exe or extension, and then you can start to open up this software. And when you do it, it will look a little bit like this, where we have our build plate, we've got our command window on the right hand side, and then we have all of our controls. So if you want to, you can actually move your 3D printer via a website, so you can actually control it while it's printing. We can also use it to analyze the temperature of our prints as they go. Now we're going to start off with our printer turned off, and we're going to use a micro USB to plug in between your laptop and your 3D printer. Now you want to make sure that you use a really high quality micro USB cable. You don't want one that can just charge, because we also need it to send data as well. So go ahead and plug it into your 3D printer and then plug it into your laptop. Now your LCD screen may turn on because it's now being powered by the 5 volts going through the USB, but don't worry, your printer is not turned on. Now you need to turn it on, and we should see some information come up on our screen. So now that our printer is plugged in and turned on, we can hear the fans whizzing, and if we go up onto Pronterface, you'll see that our port is now popped up. And the port is the connection between your USB port on your computer and your printer. For me, it is COM3, but it may be completely different for you. If you don't see anything pop up here, you may want to open up Device Manager, and you'll want to look at ports right here. And for me, it says USB serial, which is COM number 3. If multiple comms show up, then you can just unplug your printer and see which one goes away, and that's what you're looking for. We also want to go back into Pronterface, and we want to make sure that our baud rate is 115/200. This is a standard. This is basically just the frequency of how our printer is interacting with this software. So we're going to go up to here and click connect, and it's saying our printer is now online. Looking good. And then down here, we are going to be printing M303, S205, and C10. So this is a script that is written in G-code Marlin, which is the language that our 3D printers work with. The M303 is basically just saying perform an auto tune, which is what we're doing with this software. The 205, that is the temperature of the hot end, and just put in a normal temperature that you work with. Usually my very first layer is 205 degrees Celsius, but if you work with a material that prints a little bit colder, just put in whatever value you normally print at. And then the C10 is how many cycles are we running. So just doing one cycle probably won't give us a good amount of information, so we're going to go ahead and click 10 cycles. And this will make it heat up, cool down 10 times, and by clicking send, we can start that process. So you can see up here, PID auto start. And on our printer, you can see our hot end is now rising. Our bed is going to stay totally cold because we are only working with hot end right now. But as you can see, our extruder is now heating up, heating up, heating up. Now this may take a few minutes. For my printer, it takes about 10 minutes to go through all the cycles. So go ahead and have a cup of tea on me, and then come back and we'll work on the rest of our information. Okay, so now that your printer is done cycling through its PID tuning, your screen should look a little bit like this, where at the very end, it has what's called a KP value, a KI value, and a KD value. These are all coefficients for a mathematical function that we don't need to go over at all, but we do need to use these numbers to then plug it back into the machine and then send it a new report. So in our command line, we're going to get rid of this. We are going to be typing M301, which is just a saving command. Then we're going to type P, and we're going to type in whatever this number is right here. For me, it is 19.4. That is completely unique to my printer right now. It is very likely going to be completely different to yours. So 19.4 space capital I. Then I'm going to be typing in my I value, which is 1.5, space capital D, and my value here is 62.6. So your numbers should look kind of similar to these numbers, but guaranteed they won't be exactly on point. So then we can go ahead and click send, and we are now sending that, or those numbers, to our printer. Then finally, as soon as it is all done, we can go back and type in M500 and send. What the M500 does is it saves all of those settings to our printer. And now that it's done that, our hot end is completely tuned. So now if you try to print something, I want you to take a look at the home screen and you'll see that your bed may fluctuate a little bit, maybe 1 degree up or down, but your hot end will be completely stable the entire way through. Speaking of the bed temperature, now we can work on that section. So in the same line, we're going to type in M303, which is our auto tuning. It is the exact same command that we use for the hot end, but to say we're doing it for the bed, we are going to be typing in capital E -1. What this means is that we're saying extruder -1, which is basically just fill-in code to saying, hey, we're not dealing with any extruders that we have, we're just working with the bed. Then we can type in C10, which is our 10 cycles that we're going to be running, and capital S70. This means that we are going to be using 70 degrees as our bed. If you're printing on the original stock bed that's kind of grippy, then you're probably going to be printing somewhere around 55 or 60 degrees. But I usually print at 70 degrees because I very often print with materials that have a higher melting temperature. But you can type in whatever you want here, 55, 60, 70, it doesn't really matter. But we're going to go ahead and click send, and this will start the auto tuning for the bed. And again, we're going to have to wait about 10 minutes for this to fully cycle up, but at the very end, we are going to be getting some new values for our bed. So as this is running, take a look at all the places that are filled in on here, and you'll notice that as soon as we're done, we should have a screen that looks very, very similar to that. All right, so our bed has done a full cycle of PID tuning, and just like we had up here for the Hotend, now we have some KP, KI, and KD values for our Hotend. So just like before, we're going to be putting in a new line of code. But this one is going to be M304, and we're going to be putting capital P, and we're going to be entering in this value right here. That would be, for me, 178.94. Then we're going to go space, capital I, 33.83, space, and then capital D, 631.05. And remember, all of these values are purely just for my printer. It has absolutely nothing to do with your printer. All printers are a little bit different. They all have their own personalities. So we can go ahead and click send. And this has now sent all that new information through our USB into our printer. And it is sending an echo as well, saying, hey, just verifying these are the numbers you sent. So if you want to take a look at that and verify it with the numbers right there, that may be a good idea. And then to finish her off, we are going to send over an M500, which is just a save settings. So let's click send. Sending. Great. And now our printer is completely PID tuned. So now anytime we're working with it, we should get absolutely perfect values for our Hotend and our bed. So to finish us off, let's go ahead and turn off our printer, unplug our USB, and you guys are all done.